Hey everyone, Cameron Basham here. Today I'll be going over my Sprint 2 review. The reason I'm doing it in a video and not live is because it's very demanding on my PC to stream, and I don't want to take any chances of it crashing. So with that said, yeah, this is my Sprint 2 review. Sprint 2 focused on implementing the core telemetry pipeline for the toolkit. During the sprint, I built infrastructure to collect vehicle metrics, simulation events, and I distribute telemetry through a metric bus. Now, I log the run data to a disk and display key metrics in a live client dashboard. I'll start by briefly showing the sprint burn down chart, which is on your screen now. So I started with 22 points. This was a big sprint for me. I had 7 stories. I completed all 7 of them. I can show you, you're seeing it here on the right side of my screen. I have 7 issues in here, and they were, implement the core telemetry pipeline and live dashboard, vehicle metrics collection, event capture, metric bus telemetry distribution, run lifecycle management, persistent logging, and the client dashboard. I think I already said that, but yeah. So the system architecture is as follows. I run Carlo simulation in the background. I have 3 different metrics collector files that run and grab a bunch of information. They send it to a metric bus. The metric bus then sends it off and logs and then I have a logger that logs it, and I also run the data, and then that's all on the client dashboard as well, and we'll get into that here in a second. So my issue 14 was develop a metric bus system. The goal was to make it decoupled, so none of the other systems knew about each other. And these were all separate modules. They publish and subscribe to messages buses for metrics and events. I can show you my metric bus Python file, which is here. Might be a little small for some viewers, but basically I learned a lot about pipelines in this, just how to set up the architecture. I learned what a smoke test was. Basically, if you make a little test to see if your pipeline's working, and if it fails, well, if it shows smoke, then it's good. If there's no smoke, then it's clogged. It's bad. So that was interesting to learn about. So yeah, I sent all the information through here through a payload, basically, like a JSON. So I subscribe in here, unsubscribe, publish, or close, and a dispatch from loop. And this is for matching subscriptions if for some reason they're being the same. So I should also say the collectors go to the metric bus, and then the metric bus sends to the logger, to the dashboard, and to the event system. So my core components for the telemetry message data packet. Let's see if I can find that real quick. Telemetry message. Yeah, right here. Oh, not this one. Oh, sorry, at the top. So yeah, I have a topic, a run ID, the frame, the simulation time, the payload, and the wall time. And that's what's being tossed around basically through my metric bus transported. The topic can be the vehicle speed, for instance, and the payload can contain its kilometers an hour. So that would work. Yeah, so for the categories, there's vehicle speed, acceleration, steering, collision, lane of invasion. Those are events. The collision and lane evasion are events, and the speed, acceleration, and steering are going through the vehicle class. So I have a vehicle class and the event collector. The vehicle class and the event collector class. So when I subscribe to a vehicle on the handler, and that means that the subscriber receives the vehicle speed, the vehicle acceleration, the vehicle steering, but not the event collision. When the telemetry is published, in other words, when the data is published, it goes into a queue. This means it never gets clogged up, and messages are proceeded in an asynchronous manner. This is pretty mandatory with the way the simulator works. It's all real-time frame rates, so you're constantly having to send out messages and process those. As far as dispatching messages, it's just through my subscriptions here. I'm sending it out. Through a subscription ID, and we're indexing one. So a single message may go to multiple consumers. So vehicle.speed, the message will go through the metric bus, and then that metric bus will take it to the logger and the dashboard update UI, which I'll show you, which we'll get to in a second. So like I said, it's decoupled. So like the collectors don't know about loggers, dashboards, analytics, anything. Their module, that means I can add new stuff later on, fairly easy. So for the next issue, implement vehicle state metrics. So the goal for that one was just to get continuous vehicle data captured, speed, acceleration, steering. I built the vehicle metrics collector here. So this is getting the position as well, and the heading, and the brake, and the throttle. I think I didn't say that one. It's also getting a frame timestamp. And for each of these, I made a little test, but I'll show it to you all. I don't need to run these tests, but yeah, for each of these, I made a little test for each of these collectors, and I won't show you that now, but it's all working together now, so it's kind of useless showing you. But yeah, that was a lot more work I added on to it myself. I added tests to all of these. I didn't expect that. I guess I should have thought about that before. But anyway, the next issue was implementing the event capture. And here's my event collector. And so for this one, we're taking the world information, the vehicle information, the metric bus, the run ID, the collision sensor, the lane invasion sensor, which is where it detects if you're going over the lane or to go over it. And we're attaching the collision sensors and the lane invasion sensors to the vehicle. And now on collision, I can detect other actors that get hit. A lot of this Python API is pretty handy. There's a lot of stuff exposed already. I was able to find a lot of this stuff pretty easily. One cool thing was I added the impulse magnitude, so I can actually see how much like force was involved in the accident. I'll show you that in a minute. So that's the payload that gets sent. You get the run ID, the frame, the type of event, right, of the collision, other actor involved, and the impulse. Okay. Number 17. This issue revolved around the logs. I just did a whole lot of logging. And this is where it gets rather interesting. So I made a logger here, basically just going through. So what the logger does is it actually reads from files that were built during runtime. And these files are contained in here. So like for instance, my last run, F66F. So if I go to F66F here, right here, you can see that run. I have a generated events.json, which shows me all the events in that run, the metadata, and the metrics for the vehicle, right? The steering and acceleration and all that. Every frame, right? Every single tick. What else can I say about this one? Yeah, this also makes it really cool to make it make your scenario reproducible, right? So you can replay the scenario basically, like if you have the location of every single tick that you went, you could trace that back basically, right? And you could recreate the scenario, which that could be a really cool feature in the future. Number 13, I dropped down an issue. This was a lower priority, but we still got it done. This was basically the beginning of the dashboard. Getting it set up with the controls. So I also added like keybinds to start, stop. You could also press like F7 to create a custom tag, and escape is to escape. So at first it was just this little black screen, and it told you what the controls did. And then I expanded that in my issue number 18. I had a big issue with replacing. So the Carla simulator comes with a lot of examples. One of those examples I based my entire project on, which was the manual drive. It's a really big file, and I don't want to remake it. I don't want to put it in my folder, in my project. So what we're doing is I'm gonna create a HUD that's separate from the manual control. And I'll show you how that works in a minute. But yeah, so we put a lot of stuff on there. I put a lot of stuff on there. I put the run status, the speed, acceleration, steering, and there's like a log of events. So I will now show you the demo in progress. So right now I have Carla server running. So now I want to run the manual control. This is the basis of the project, right? The manual control, everything is based off that. So if I run the manual control, so now you can see I'm in a little van here. And like I said, this manual control came with some basic stuff. So I'm kind of basing my project off of this, but just a little modified. So now we go to our PyCharm and we run Python run control smoke. We get this little black screen here for now. And the run right now, as you can see, is stopped. The ID is nothing because we haven't told it to go yet. speed 0, acceleration, everything. So now, if I press F5, oops, oh, I guess that's one problem. You have to make sure you're in this window and not in this window when you press the controls. So I gotta that's something I gotta remember myself. So if I press F5 here, it says running. I get the ID, which is randomly generated. In the console here, I see run started, ADD89. So if I look here, it's already generated here, and we have some stuff coming in. The metric CSV shouldn't be this full. That's interesting. I'll have to take a look at that. Weird. Because there should be nothing there. But anyway, so let me drive around. And as you can see, I get some lane evasions in my terminal there. I broke my lanes. Let's crash into a traffic light. Let's back up a little bit. Let me just crash into a car to show you that it will show you other actors. You might have seen traffic light pop up, but yeah, there it is. Other static car. And you can see right there the force. I'm not sure if that math is correct. I might have to double check that, but yeah, so now if I go back to my run controls client, I can hit stop. And now you can see it run stopped. And again, repeats the ID, so ADD89. So if I look for ADD89 here, and let me expand this right now so you can see. We got events JSON, so everything I just did, all the events that were detected, right? All the lane evasions, the collisions, those were all detected. Let me see if I can find a collision. Weird, because it came out on the terminal. But yeah, so I have some minor bugs here and there. This was, like I said, the hardest sprint I think of. So, like, I think it's gonna be the hardest of the whole project. So the metadata came in, cloud, and I'm gonna play around with some of these settings. And like I said, the metrics came out, but like I said, I don't know if this is correct or not, so I will double check this as well. But yeah, I hope you enjoyed watching that. My closing statement. So I just want to say that later on, after this, because of the sprint, I can be able to replay the run conditions. I can analyze the driving behavior. I can compare different runs. I can build graphs. Perhaps I could train ML models on it. I can debug the simulation scenarios. All the vehicle metrics and simulation events are now collected, and they're distributed through a metric bus, logged to the dataset, and they're somewhat visualized through a live client dashboard. Yeah, so this sprint laid the foundation. Next sprint is going to be a web-based analytical dashboard. So, yeah, thanks for watching.